Now, our final speaker before the break, another break, is Professor Jing Guoqing, the Professor of Highway and Railway Engineering Department from Beijing Jiaotong University, China, and he will be talking about the smart railway monitoring and evaluation technology.
Ladies and gentlemen, I'm Jing from Beijing, and it is my honor and a pleasure to share the state-of-art industry and the research carried out in the world, not only in China. The topic of today, my presentation, is railway infrastructure smart evolution, mostly by robots. Okay, this is the outline of my presentation. First overview, and then problems and challenges, and then the prospect of research and application in China. China is a developing country with a huge network. For example, for the past 10 years, we increased with another 50,000 kilometers of railway and almost 10,000 kilometers of metro system. It is a huge market as well as lots of industry oriented. This is network of development history of China. And the operation speed, you can see, like 50 years ago, we share the same speed level, normally less than 80 kilometers per hour. It's true, I would like to emphasize that from 1979 to 2007, it took us 10 years for 6 rounds of speed up, increase our speed level to 200 and 250 kilometers per hour. In fact, by 2007, we have more than 8,000 kilometers of railway after speed up can run at a speed of more than 200 kilometers per hour. At that time, we become the biggest network in high-speed railway. At that time, not only for speed up, 1 or 2 railway newly built, the speed is just 200 and designing speed 250 kilometers per hour. And 2008, our first high-speed railway designing and operation speed is 350 kilometers per hour. Now, Beijing-Shanghai high-speed railway, the speed is 350 kilometers per hour. For example, like 20 years ago, from Beijing to Shanghai, it took 24 hours. And about before 2008, from Beijing to Shanghai, it took 10 hours. But now it takes less than 5 hours. Normally, the high speed is 4 hours and a half. Now we are testing. We spent 3 years testing the high speed 400 kilometers per hour. This is speed. For our inspection technology, normally we have 2 types. One is static geometry inspection based on like gauge, ruler, trolley, absolute and relative method for track quality. This is static. And we also developed dynamic track geometry. We import the technology from other countries and develop our own system, generation by generation. Increase the speed, increase the system, increase the the software for analysis. And this is the high-speed trains in evaluation, the track quality. For example, this one, we have more than 13 high-speed inspection trains with a speed of operation 350 kilometers per hour. This is fleet is run by China Railway Academy of Science. responsible for all the China 50,000 kilometers for high-speed rail inspection, each month with twice of inspection. And we also have other low-level track recording vehicles attached to run by the railway companies, 18 railway companies. And for our track inspection, in the past, we mostly depend on labor, manual, and start from like 15 years ago, we developed computer-aided, like big data, like a sensor, like manager analysis. Nowadays, we most of our result analysis and censored by computer science. We call it like a smart management system. This is our maintenance management system, like the standards for railway maintenance, periodically maintenance, and centralized maintenance, and how to say now, like from like before COVID, we decided to depend on predictive, mainly preventive maintenance, but mostly we call it like centralized maintenance. This is our maintenance management system. Now we talk about the problem and challenges for the China Railway track maintenance and evaluation. The problem is laboring, the first one. In the past, for example, like 5 years ago, 4 years ago, every year China have more than 20 million newborns. But last year we only have 9 million. It is totally sharp downsize of reduction of labor. This is the first challenge for us. This brings us some economic issues in China. And also the second one is high cost labor. Each labor in China, for example, about at least 1,000 US dollars or euros monthly, the salary. And we all know that the track quality inspection, we call it 4DS. Difficulty, dangerous, dirty, and boring, and dull. No new young people like to take the railway inspection working because it's subject to human experience, time consuming, and mostly working in window time, which means very late at night. Young people even prefer to take work as a deliveryman, a mailman, take the scalper, run across the city, and the salary still paid very well. So this is the problem for Chinese railway maintenance. Another thing, in fact, in China, we have more than 800,000 railway workers for railway maintenance. But in the past 10 years, we increased our network, but our railway employees, no increasement, which means that we have less employees per kilometer of network. Okay, I think this same thing will happen in Thailand maybe 10 years later. This is our challenge. We want to use less labor, reduced cost, and in nowadays, China, we develop robots. Robots, for example, if you travel in China, the restaurant, the hotel, there will be lots of robots for serving the calls, delivery reception, and even for like how to say guard system. It's very popular during the COVID, and it has become a very popular industry for China. So lots of young and startup companies working on railway robots, for example. Another solution is UAV for inspection. But there are problems in China. For example, the first thing is rights for flight. because in China we have a very strict space rights control system. For example, in Beijing zone, all year round there is no allowance for UAV operation. The second one is pilot qualification. But now we have the laws for these regulations. But railway, for the UAV, for railway, they have many good advantages in, for example, the safety inspection. Everybody knows that lost railway went to operation, put into operation, because there is no fencing, there is no railway regulations. Local people stole away the parts, fasteners, and result in big problems for the railway safety. Now we employ UAV for monitoring, for parallel, for safety. Because in China we have many railway overseas products. For example, the same thing happens in Siberia. There is no regulations, there is no fencing. So there are lots of problems like violate, steal, and the local animals run into the track, onto the track. But now we are using UAV for patrol, for management. Another thing is one of my research products, we use UAV for desert land, sandy track. Before and after sandstorms, we use UAV for the sand drift accumulation, distribution. Then we can make a decision for resources for maintenance. Okay. Now we talk about railway robots, and this is one from review paper I wrote it with my team. This is like a challenge perspective of railway inspections. There are many railway robots companies in the world. For example, the first one is Italian. They provide this. The first one. The second one is EU research product. It looks ugly. The third one is RailPod from American companies. This is automatically can run on the track. Another thing I want to mention that on the BKK airport, Bangkok airport, I saw automation robot for cleaning. This is my first time to see it in Thailand. I think why not put it into railway and highway like maintenance. This is China's, we have like 6 companies developed in China focused on railway robot. The first one, Shenhao, is one of my collaborators and use railway robot for track quality, fastener, as well as the profile of track. The second one is GD inspection robot companies. And this is what we did. We did the test in window time for the tracker, for the fastener missing, profile. Another thing I want to mention that the robot and in the market is less than $2,000 US. And this is one of the trial products carried out in Netherlands. It's like carry on to reduce the trouble and labor of the railway workers. I think in the future with technology of battery, and we will have more robot pair with inspection engineers, reduce the trouble and the loneliness. Okay, this is a track fastener robot developed in China with cars and my team. The first one on the left side is, okay, left side robot or fastener. It can install and deinstall the robots, the fastener, to remove the trouble of the workers. So this side is bigger one for all the fastener installation and deinstallation cleaning. A very big one, but we have trouble in putting it into operation because China Railway Department has a very strict standards for this vehicle put into operation on the track. We have standard as strict as a vehicle of rolling stocks. So it is still put into, how to say, the storage. And we also have the robots for the undercar inspection. We have 3 robots company in China, and we have this robot used in China railway companies as well as metro companies. We export to Hong Kong and Singapore metro system. It can reduce 80% of the engineers for inspection, and with cameras and before and after for analysis, very quick, 15 minutes, automatically run. And this is one for the roof inspection. We also have the robot for OCS, overhead catenary system inspection, especially for the metro system. There are also railway robot company developed in China and in the world for the railway bridge inspection. This is like our categorization, and this is also some examples from France and other countries for different type of application. And there are lots of bridges in China across the river. So in the past, we use divemen, normally retired from the military service, and dive into the river to detect the pirates. But now there are many railway robots company develop robots to detect the pirate, like the corrosion, damage, and use data analysis, computer science to analyze, to provide a report. For example, for our Changjiang River, for our Yellow River, the big, and even for some bridges across the sea. This is maybe this one. Okay, there are these are products from like Hamburg and EU product, but we also have our own system. But I think our system looks so ugly, so I don't present our photos here. But how to say, the Hamburg and EU product design looks handsome and smart. So we use this. Each of this machine is about 1 million, more than 1 million RMB, but it can reduce the labor and work of railway workers. We have the system with, for example, GPR, with laser, camera, for all kinds of non-contact evaluation of the tunneling, lining, as well as like a profile, falling rocks. This is the one interesting from Japan. You know, Japan and Korea, they have like 20 years advanced than China, which means they have more senior citizenship than China. So with the aim to reduce the travel and laboring, they use VR plus like an operation robot to do some overhead OCS maintenance work. Interesting. And next part is part of my team research and perspective for the future. Okay. In fact, for the past 20 years, I have been working on ballast track, like ballast, sleeper. You know, almost China huge scale of railway construction is coming to an end. Most professors shift from structure dynamics to evaluation. So this is my global vision about the future railroad inspection. And let's first is smart sleepers and INSA, as well as GPR and robot. This is product from Netherlands, RILA. In fact, China and France, many countries develop a similar on-board inspection system. Sensors, we have our own system. This is quite efficient and less expensive. I think this system could be valuable for most developing countries of track quality inspection. This is GPR, and I noticed that Thailand has one high rail company developing rail infrastructure inspection. We developed GPR for track maintenance, during the COVID, we have tested more than 30,000 kilometers of ballast track in China. And this is our system detection, inspection, and also validation. We set up a track of 30 meters for different ballast quality for validation our GPR system. This is my publication during the past 4 years. This is a manual, but we normally during the operation, we just install it under the car body. It can run at a speed of 160 kilometers per hour, and collect the data, and then my team make analysis, and then make a report to the railway company for maintenance, for tamping, for cleaning. It can detect like the moisture, the fall index, as well as the thickness of ballast bed. This is my research. This is relay system developed. One of my former students worked for this company. So and other countries like Germany, as well as America, they also have similar product and service. And we also have our own system on board, sensors to detect the track quality profile. But this one is special. It's in front of the car body. In China, it is forbidden to install it in front of the car body. Most of our onboard system is in the car or under the car body, not in front of the car. Now we talk about smart sleepers. In the past, the sleeper is just one important part of the track, keep the geometry and distribute the force to the substructures. But one idea occurs to me, why not make it smart? Which means to install sensors to record the dynamic acceleration and to, recover the energy from solar. So inspired by several companies' products, we published a review paper, 2 review papers. And one of my former PhD working with CNTS, we published several papers, make the sleeper sensitive to deformation. This is the carbon nano sleeper, which when we add the carbon nanotube to the concrete, the concrete sleeper deformation will result in electricity resonance change. And then we collect signals weekly, monthly, so it can become like a smart sensor or recorder. If we put 10 or 20 smart sleepers along the track, it becomes like a structural health monitoring system, cheaper and reliable. This is one of our ideas. And since we did the test, like calibrations from the material to the small beam and then to a real sleeper, and dynamic as well as static loading to test like the resistance, in fact, the signal of electricity. It works very well, and this is one of our ideas. Next one is piezoelectronic sleepers. And green railway as well as digital railway is always the trend of the railway development. So why not to collect the electricity due to the cyclic loading of the passing train? So one of my master students working on this to buy the sensors, installation during the concrete sleeper fabrication. But this test does not work very well because of the pre-stretched concrete sleepers. There are too many steel bars. Next step, we will use composite sleepers made of plastic or rubber. So there are no confining or disturb steel bars. Next, we'll talk about smart ballast. And smart ballast, in fact, this idea was initiated like 10 years ago by UIUC and put sensors into the ballast and 3D printing, things like that, to make the ballast become smart, and we can get the response of like dynamic acceleration, displacement. One of my research is use machine learning to predict the ballast breakage. We validate 5,000 ballast particles under the crushing machine, and to test then we can predict the ballast breakage due to the loads. This is one of our papers. Next, by conclusion, and I think smart robot as well as smart track could be used for the future railway track quality evaluation as well as health monitoring. Artificial intelligence technology to improve the level of intelligence. My team, 1/3 of my students working on machine learning, computer science, with background of software, civil engineering, but from the master degree, 3 years, totally working on computer science, like machine learning, AI, together with like automation engineers, electricians, sensors, and in the future, in my opinion, it will become, a system from the substructure, the track, as well as the train, work even from the aerial, like satellite, like a link from Moscow, working together to make all time, all space to monitoring the track or the safety of train operation. Okay, thank you, and thank you, that's all.